Hello, good morning. It's still May, and today's live stream is about these amazing worksheets that Jeff Kutcher has designed to help support children as they really wrestle with understanding the addition and subtraction standard processes, the written methods for column addition and subtraction. When we teach them, we try to teach understanding, and often we assume we have when a lot of children really haven't deeply decomposed what's going on here. And these worksheets are here to enable a full and wide conversation to take place. I'm going to explain them in just a minute. Hi, good morning. If you're watching, it'd be lovely if you said hi. If you've got any questions, I will, of course, answer your questions. So a few weeks ago, I published these worksheets. There were 4 of them on visual addition and subtraction with and without exchanging, and they went down really well. Feedback was excellent, so led to lots of interesting conversations. So I asked Jeff to create these, and he's done just an amazing job. As with all Jeff's worksheets, they're free to download in my Facebook group, which is Expert Primary Maths Teaching. If you go to the About section of this channel, you can find links to other places that you can download them. Hi, you can see more people are joining us. If you would like to say hi, that'd be great. If you've got any questions, please do ask. And in each set, we've got questions with no exchanging, questions where we're just exchanging ones, questions where we're just exchanging tens, questions where we're exchanging twice, and a sheet of mixed up questions where there's actually one of each. So you can pick exactly what you feel is right for your group, and you can always click through to auto generation worksheets where it'll generate as many as you like of these with different examples on the same theme. So let's look at what's going on with addition first. Just grab my board so I can write more easily. Okay, so when we've got questions like these, thank you for the compliments. When we've got questions like these, children are simply counting all to find the answer. They can see the 223, they can see the 145, they just have to puzzle out what's going on. And as they work on them, quickly they should realise that they're gathering the hundreds, they're gathering the tens, and they're gathering the ones. Therefore, as we start to lay this out formally, I'll just take this second one because I've got some space. The idea of using column addition should make sense because column addition puts these ones next to each other. Of course, we can label those headings. I'm just a little tight for space. We've got 2 ones and a single one. Put them together, we've got 3 ones. And it brings the tens digits nice and close together. 4 tens and 3 tens is going to be 7 tens. 2 hundreds and 2 hundreds here is going to be 4 100s altogether. Now, as an experienced mathematician, I've started with the ones, of course. And that's not obvious to children, and it's not obvious here. When there's no exchanging, there's no need to start with the ones. But it's nice as we're working with children just to prompt them that, look, I start with the ones. That's not explained yet. It's not logical as to why, when I've spent all my time teaching you to read left to right, that we're working right to left. But I just do it because I know it's going to help me later on. And this column addition brings the numbers that we're adding so close to each other, makes it really easy. And the next worksheet, when they're perfectly comfortable with that, just involves exchanging ones for tens. So here, where have I got? If I work on this bottom one here, because I've got some space where I can set it up here. So I'll just section this off so we can see I'm just working on this bottom question. 248 add 437. And we'd allow children to work on that organically, to understand that it's going to be 670, and then we get a little bit stuck because we've got 15 in the ones and we have to puzzle out how to work with that. And they should be able to find an answer that they're comfortable and confident with, if possibly with a little bit of support. And as we set that up, 248 as a column addition, 437, just going to add there. We can actually work right to left as well as left to right as well as right to left and see what happens. We're going to get 670, and then we've got the 15, so it all goes a bit wrong, gets messy. Let's just do that. 670, sorry, 4 and 3 is 7, and then we've got the 15. So we're going to have to cross out and turn that into an 8 and make that a 5. So it's quite messy. And we start to see the benefit of working right to left because that mess disappears. 2, 4, 8, add 4, 3, 7. If we work right to left, we see the 15. So we've got 5 in the ones. We pop the 10 from the ones there, and then we can see, and it's all right here in our 10s, we've got 4 and 3 and the one that came from the ones. So we've got 8 10s all together, and then we've still got 600s. And that's why it's so much better to work right to left rather than left to right, because there's no crossing out. The third worksheet in the series involves just exchanging 10s, so we come across the same issue. But the fourth one involves exchanging twice. And that really reinforces this idea that it's only sensible to work right to left. It's such a mess if we work left to right. Let's just look at this question here. 269 and 388. Because it's visual, they can wrestle with it themselves and puzzle out an answer they're happy with. But when we lay it out, 269, add 388. If we work left to right, we've got 500s. That's very logical. We can see those 500s. Then we've got 6 10s and 8 10s. What do we do now? It's going to be a mess. So we've got 14 10s, so we're going to have to make them 104 10s. So that becomes a 6, and we've got a 4 here. But then we've got 9 ones and 8 ones, which is 17 ones. So that's going to have to be a 5, and that's a 7, and it's all horrible. But if we lay it out working right to left, we can see how it all flows and we get our answer very neatly. We understand that these methods are just here because they make everything neat, they make everything work. And other methods do work, they are valid, but they're just messier, which is why we prefer the one we use in the standard way. And there's a fifth worksheet in this series, as I said, which simply has one of each type of question. One where you're not exchanging, one where you're exchanging ones, one where you're exchanging 10s, and one where you're double exchanging. So that might be suitable for older children as a check that they deeply understand what they're doing. Possibly you might work through the other 4 worksheets as an intervention and then come back to this one later for consolidation of that intervention. But like I said, you can generate as many worksheets as you like. Let's have a look at subtraction, because subtraction is different. So once again, we've got 5 worksheets here. This is our first worksheet, which involves no exchanging. So we start with 185, subtract 171. Now, the first thing to understand is that as a teacher, you've probably got an idea how you think all the children are going to work on this. But in reality, they have different methods. It's one of these things as a teacher educator we're constantly trying to make teachers aware of. You've got your head around it and you're really excited because you now see how it should work. But then you have to slow down and tune into what the children are seeing. So just to understand, you might try this as a takeaway. So we want to make 171 disappear. So we can cross out 100, we can cross out 7 tens, and we can cross out a single one and see what's left. Or we might see it as a count on. So we are partitioning off the 171 to try and see what's left to get us to 185. Either way is fine. When we and if you're working on it visually, it's nice to make the links between the two ways and give them both validity. And there are other ways too, actually. Some children are seeing this more in the abstract and they bring that in. So just slow down, cherish the talk, cherish what they're doing, and then gradually bring them together, possibly in groups, possibly one-to-one for children who are struggling, possibly as a whole class. It's your judgment to set up this algorithm. So it's about noticing. But once again, with the no exchanging situation, it's really simple because we can focus on the ones. 5 subtract 1 is going to be 4. Then we can focus on the tens. 8 tens subtract 7 tens is going to be 1 10. And then the hundreds. 100 subtract 100 is gone. And so we have an answer. And we can link that up to be a counting on answer or a what's left when we've taken away. And of course we can check, if you're thinking it was counting on, we can put these two back together as an addition and check we get that as the answer. So much going on with subtraction. So we've just got a plane coming over. Hope it's not too noisy. And then, of course, there's plenty of practice here as we're setting it up. It really is tricky. That's why children struggle. But by giving them the visual representation, and ideally the concrete representation as well, when they get stuck, when they've forgotten the written method, they should be able to figure it out anyway by rebuilding the visual representation. So we're not just relying on the rote learning algorithms. They should have those algorithms, those written methods fluently in the end, but it takes quite a while. So let's look at what happens when we start to exchange. 173 subtract 134. Well, if we do this as a takeaway, we can take away the 100. We can take away the 3 tens here. They're gone. So all of that is gone. So we've got 43 left, but we're trying to subtract 4 now. So we could do it like this. There's lots of ways children could cross this out and see what's left. There's 39 left. Can you see the 39? 3 whole tens and 9 ones, where we've subtracted off the 3 ones and 1 from the tens to remove the 4. So the answer is 39. So we can confidently see that answer. Now let's try and apply the written method. So it's 173 subtract 134. And if we've just done lots of work on addition, we can hopefully encourage children to start with the ones. Look, we can't subtract 4 ones from 3 ones. We just saw that we couldn't do it. We had to break into one of the tens. So if we put one of the tens with the ones, we get 13 ones. But we've only got 6 tens left. The 13 ones now subtract the 4 ones. We could do that. We can show those 13 ones. We've got 9 ones left. And now we've only got 6 full tens left because we used one of them. and we are subtracting off 3 full tens, so that is 3 full tens, and then the 100 subtract the 100, that's gone. And there we have our 39. And if they've already convinced themselves it's 39, they're likely to be very happy with that method. And we could try working left to right and see how messy it gets. There's a few more examples like that. We have a worksheet where we're exchanging 100 for tens. We have a worksheet where we're exchanging twice, and there we really do see the benefits of looking at it as a counting on rather than a subtraction. It's much easier to do with mental methods, but we can encourage children to work on their column subtraction even with these. So if we look at 522 subtract 137, we get to a sense of how difficult that is to do with apparatus or visually. We can easily subtract off the 100, but when we get to subtracting the 30, well, we're going to have to break into 100. There's the 30 gone, but we're down to 90 here. And to subtract off the 7, we're going to have to break into another 10 and subtract 5 of those. So we can see the answer is 385. We can see how tricky getting it is and maybe appreciate the column method. Let's just do that. 522 subtract 137. And by this stage, we want to remind children we're starting with the ones. We could not subtract 7 ones, so we had to use a 10. So that took us down to 110, and we had 12 to play with, and we can draw that out here. The 12, subtract the 7 is 5. And then we only had 110 left, so we had to break into an 100, which gave us 11 tens and only left us with 4 100s. And we subtracted 3 tens, that gave us 8 tens, and we're left with 4 hundreds to subtract the 100 from, 185. But it's so much more powerful if the children have already convinced them that themselves it's 185 by any method. And then there's a final sheet with mixed examples as before. See, there's still a few people watching. If you've any questions, please ask them now because I'm going to finish up in just a minute. As I said, those worksheets are available for free download from if you go to the About tab on this channel, it takes you to places you can download them for free. One of them is in the file section of the Expert Primary Maths Teaching Facebook group, where you can find all my worksheets free to download, and they all have links that click through to Jeff's site where you can auto-generate more worksheets. Okay, if there are no questions, thank you so much for watching. Have a great day. Bye for now.